Joining us today is Steve Ostanek, the president of Neundorfer, based out of Willoughby, Ohio, and he's joined by Spencer Tibbs, computer engineer. Welcome to you both.
Thank you, Chris. Hi.
Steve, can you start off by telling us a bit about Neundorfer?
Sure. Neundorfer has been involved with heavy industry, primarily around air pollution control equipment for near 45 years now. We are consultants and engineers who create customized solutions to improve emissions and increase efficiencies in these heavy industrial processes.
Great. So, Spencer, can you tell us what is a precipitator optimization system?
Yeah, so the precipitator optimization system takes in controls that are out in the field, wrapper controls, voltage controllers, and kind of monitors and sets programs around performing the best task at hand in terms of collection efficiency and making sure that we're not out of opacity limits and stuff like that. Yeah, so we have our proprietary in-house controls for wrappers and voltage controllers, the MVC4 and the microwrap. We've built our own drivers on VTScada's platform to communicate to those. And we are logging data every 5 seconds and getting an indication every time a wrapper is hit. And then we have other performance optimization things and a bunch of different programs that we can set up around those pieces of equipment. And then from the plant level, we communicate with a DCS system. So we have our own DCS package that we have set up multiple times to put stuff into Pi for the customer so they can have it at the plant level as well.
So when you say when a wrapper is hit, what exactly does that mean?
It's a 20-pound slug. We energize it. It's a magnetic slug and it drops and then picks back up using our wrapper controller. And then we set programming around that of how often it should wrap and its frequency, when it should wrap, when it shouldn't wrap. So we kind of do a lot around our own controls.
So you mentioned VTScada software. Tell us a bit more about how VTScada works in this process.
VTScada is, for us, we built off of our own custom OEM layer. Mm-hmm. And we have now supplied numerous applications where we have a custom application for our customer that's built on our OEM layer. VTScada has been great to provide us the tools to build our own thing while still utilizing the stuff that has been provided.
So, Steve, you've been using VTScada for a very long time. How did you come to actually discover this product?
In the late 80s, early 90s, there was a emerging need to interface all these devices that Spencer talked about. On a particular precipitator, there could be hundreds of these devices. And then in a particular facility, there could be multiples of that. As emission standards were getting tougher, our clients were needing to stay on top of this equipment better and get the data and do something with it. And we tried to create applications in DOS. And then Windows kind of came around and Windows afforded us abilities to do things with graphics and that. It just seemed clunky at that time. So I would say mid 90s, late 90s, we were introduced to a guy by the name of Pat Cook. You heard of him, Chris?
I've heard of him.
So, he said there's this wonderful tool out there that could make our lives easier. And we looked at it, and the benefit was in these industrial settings and in these plant kind of integration efforts, you're trying to take this thing that's on an island and integrate it into a plant. We would have to create those means of interfacing with plant DCS systems and such. VTS, everything was just packaged in there. And it just made it easier for us to, if someone wanted us to interface to an Allen Bradley or Modbus or something like that, we didn't have to create it. It was already done. And then the data historian was built in, and that was an advantage. So the tool made our lives a little bit easier, when we're trying to do this integration. And then over those 2 decades or so, we've been able to build on top of this and build more functionality and more troubleshooting tools, more diagnostic tools, and optimization tools into this that helps our customers optimize their equipment.
Thank you. So, Spencer, as I understand it, you've created basically a templated version of this application, and you'll be able to then roll out specific applications to individual customers. So can you just tell us a little bit about what each of those applications that you roll out includes?
Like Steve said, we interface with 100 devices. So some of the precips could have as little as 6 voltage controllers to 120, depending on the size. So built in our layer, we were able to just make a tag type that is a voltage controller. And from a scalability standpoint, we can add 100 of them quickly, and then we can get those up and running and commissioned very quickly as well. And same with the wrapper controls. We have systems where we only have 1 wrapper control to 8. We've been able to build custom layer that we can scale, so we're not having to spend time writing this over and over again for all the different devices we've handled.
Spencer, would you mind taking a moment to actually show us an example of one of these applications?
Yeah. Okay, so this is the general POS layout. It's a top-down view of the precipitator. Here are the voltage controls that we have, where if you hover over them, that brings up the control panel that you would actually see out in the field. We can click on this, go to remote view, and you have full access to what's actually out in the control panel. You can change settings, stop the voltage control and start it. These are also our wrapper indications. So if I hover over one, it lets me know that this wrapper is actually hit, and then letting me know the next one is ready to hit. So we can go to our wrapper control, we can do programming, check on the control status of it. There's a lot of things that we can tailor around the precipitator in terms of power off wrapping, specialized wrapping. We also have built an oscilloscope, which I ran one earlier. So it's just like your regular digital oscilloscope. Here's our triggers down here. You can start and stop the scan, and then you can do different waveforms. And this is where it's actually triggered. You can move this around. So it's really nice for diagnosing the actual voltage control in the field, as opposed to bringing a handheld oscilloscope out.
There's a significance of the oscilloscope function, and it's around safety. These controllers are in cabinets and individual cabinets, and inside that cabinet is 480 volts. The traditional method of hooking up an oscilloscope, and an oscilloscope is a very valuable troubleshooting tool, is that you have to open the door to the cabinet. And of course, everything that you want to attach to is in the back of the cabinet. So you have to potentially break the 480 plane. So that oscilloscope function allows us to do things without even having to go to a control room. So what an operator would have to do, or a technician would have to do, is get up, walk out to wherever these are, open a cabinet, potentially get exposed to a dangerous situation. Now you can just sit at a computer and look in oscilloscope trace, and we can remotely look at it as well. So that was a huge tool there, and it's one of those little insignificant things. You go big deal from an electrician standpoint, pretty big deal.
We've incorporated chart effects, and we've made a 3D graph. And so here you can see the lanes and how they're running. You can click on different sections. You can go back historically with data. And so it's just a nice, helpful visualization tool for our consultants and then the customer as well. And then, we mentioned our DCS. We have a DCS table already built out. This one's in Modbus. So it just makes a nice, quick, easy setup for our customers to attach to, using the drivers that have already been established by VTScada. We like to think that our stuff is very plug and play, that we do just the work of getting it laid out and performing this HMI layout, and then we can just kind of turn it over to the customer, and they plug in their DCS communications, and we land the field wiring out to the devices here shown, and it's ready to go.
That's great. Do you use any of the built-in VTScada trend viewer?
Yeah. So if we go here onto our little pop-up, click trend, and there we've pulled up that individual voltage control. If the operator starts and stops the TR, it triggers a note into the notebook. So it's very helpful for diagnosing this stuff, especially if we have customers utilizing the security credentials that we've provided, with different operators. the trending is absolutely wonderful, and we live off the trending.
Well, I've been working with Trihedral for about 11 years, and Neundorfer has been a household name throughout that time. And I've seen many really impressive looking screens. So it was a pleasure speaking to you in person and getting to see that application in motion. Thanks for joining us today, gentlemen.
You're welcome.
Thank you, Chris.